welcome back to our channel Easy Mathematics. As a continuation topic, today we are going to discuss about bijective functions. So in last two videos we discussed about one function and onto function. So now we know what is one function and an onto function. So when we can say, suppose f is a function from a to b, when we can call this f as a bijective function. So we can call f as a bijective function if f is both 1 and onto. So if a function is both 1 and onto, such functions are called bijective function. So a function which is both 1 and onto is called a bijective function, or simply bijection. To get idea easily, here I am going to represent this bijective function using arrow diagram method. Let f be a function from a to b. Suppose a and b are two sets. A contains x1, x2, x3. B contains y1, y2, y3. Suppose, and f is a mapping from a to b. F is a function from a to b, and x1 maps to y3, x2 maps to y1, x3 maps to y2. So here image of x1 is y3, image of x2 is y1, image of x3 is y2. Then next to my question, is it an example for a bijective function or not? So this is an example for a bijective function. Why it is a bijective function? Because in domain, different element has different images, isn't it? x1 has only one image, that is y3. x2 has one image, y1. x3 has one image, y2. Different elements in domain has different images, so it is 1, isn't it? So the given function is a 1 function. Then next we want to check whether it is an onto function or not. So to check onto function, we want to concentrate on codomain part of this function, isn't it? So every element in codomain must have at least one pre-images. So y1 is an element in codomain. What is its pre-image? x2. y2, its pre-image is x3. y3, its pre-image is x1. So every element in codomain has pre-images. So what we can say, this function satisfies the condition of onto function. So a function f is both 1 and onto, so it is a bijective function. So this function f from a to b defined like this is an example for a bijective function. From the above example, we can conclude one important condition for defining a bijective function. Suppose f is a function from a to b. If we want to define a bijective function from a to b, number of elements of a and number of elements of b should be equal. So if n of a and n of b are equal, then only we can define a bijective function from a to b. So very important one condition to define bijective function from a set to another set. So to define a bijective function, number of elements in domain should be equal to number of elements in codomain. So one more condition we want to consider here. Let f be a function defined on a set A. So what is meaning of this? So f be a function defined on A means its domain and codomain are same set A itself. So f is a function defined on A means f will be a function from A to A itself. That means domain and codomain of the function f will be equal to this set A. So next we want to check how practically we can verify the given function is bijective or not. So for practical verification for bijective function, we want to verify both 1 and onto case. So how we can verify 1? To verify 1, we want to start with f of x1 is equal to f of x2, isn't it? So what is given question here? Show that the function f defined from r minus minus 1 to r minus minus 1. So domain and codomain are same. From real number we are eliminating minus 1 alone. So all real number except minus 1. And function f of x is defined as x minus 3 divided by x plus 1. Then from domain, why we are eliminating minus 1? If we are substituting x is equal to minus 1 in the given function, denominator part becomes 0. So that is why we are eliminating minus 1 from domain. So to find f of x1, in f of x we are replacing x with the x1, that's all. So x1 minus 3 divided by x1 plus 1, that is equal to f of x2 means we are replacing x with x2, that's all. x2 minus 3 divided by x2 plus 1. Then cross multiplying both sides we get, so we are cross multiplying, then x1 minus x3 into x2 plus x1 is equal to x2 minus 3 into x1 plus 1. Then opening bracket we get x1 x2, we are multiplying x1 with these two terms, opening bracket, that's all. So x1 x2 plus x1 minus 3x2 minus 3, that is equal to, here multiplying this two bracket we get x2 x1 plus x2 minus 3x1 minus 3. So from both sides what we can cancel? From both sides first we can cancel minus 3 minus 3. Then next we can cancel x1 x2 x1 x2. Then from both sides I am taking all x1 term to one side. So x1, this minus 3x1 I am taking to this side. So it become plus 3x1. That is equal to, here already one x2 term is there. I am moving this minus 3x2 term to this side. It becomes plus 3x2. So from left side we have x1 plus 3x1, that is 4x1 is equal to, from right side we have 4x2. From both sides what we can cancel? 4 we can cancel. Then we get x1 is equal to x2. So from f of x1 is equal to f of x2, using the procedure simplifying the terms, we are able to prove x1 is equal to x2. So what we can say? The given function f of x is 1 function. So given function f is 1 1. Next we want to check onto condition. So to check onto condition, what we want to start from, where we want to start? For every y belongs to codomain. So here codomain is r minus 1. So I am representing it as code because domain and codomain both are equal here. So for every element from codomain, if we are able to find an x satisfying the condition y is equal to f of x, then we can say function is onto. So we want to find an x in domain satisfying the condition y is equal to f of x. So we want to start with this one. So to check onto condition in every function, we have to follow the same procedure. So y is equal to f of x means x minus 3 divided by x plus 1. Then from this equation we want to find value of x. Cross multiply and simplify. So I am cross multiplying and simplifying this terms. Y means y minus 1, sorry, y by 1. So cross multiplying and simplifying, we get xy plus y is equal to x minus 3. All x term I am taking to left side. So xy minus x, this plus x moves to this side, become minus x. Then plus y I am taking to this side. So minus 3 minus y. From left side, what we can take commonly outside? X we can take commonly outside. So y minus 1 is equal to minus 3 minus y will come. So we want to find value of x. So what is x value? Minus 3 minus y into y minus 1 moves to this side, become y divided by y minus 1. Then minus sign I am taking commonly outside. Then what will come? 3 plus y, minus of 3 plus y divided by y minus 1. Then if I am taking this minus sign in denominator, then what will come? 3 plus y divided by 1 minus y. So x value is 3 plus y divided by 1 minus y. So next we want to check for every y belongs to codomain, such an x exists or not. So y is an element in codomain. Codomain means all real number except minus 1. So if I am selecting y is equal to 0, what is value of x? 3 plus 0 divided by 1 minus 0, that is 3 by 1, 3. 3 is an element in domain, isn't it? We can find element in domain. So 3. Different y values from codomain, we are able to find such an x satisfying the condition 3 plus y divided by 1 minus y in domain. So what we can say? For every y belongs to codomain, there exists an x in domain satisfying the condition y is equal to f of x. So the given function f of x is equal to x minus 3 divided by x plus 1 is a bijective function. So this is how we practically check whether the given function is bijective or not. So we want to consider one case and onto case separately. We want to prove the given function is both one and onto. Then we can say the function is bijective.